Hello, everyone. This is Eddie again. Welcome back. I know it's been a while since I've done a post, but finally have some time, so I'm gonna take the time to work on teaching you some more about Python. So I believe this is the third video where this is a series of going over the basics of Python slash doing some examples. What we've done so far is just go over the introduction to the syntax, getting used to Python, and then the second one was going over how to web scrape because that's how I learned. So I feel like if you can pick up on being successful at making requests and how to manipulate and clean that data, you're one step closer to being a little more competent in Python. Today, what I wanted to go over is how to plot what we've done. So, as a review, what we did was we went on this website, Pro Football Reference, and we scraped these two tables here of the standings, and we extracted things like the team name, the team link, and their respective stats. Now, what if we wanted to visualize that data and plot it? Well, luckily, if you're a sports fan, there's some pretty creative ways you can make some cool plots. Like you could plot things like player headshots, you can plot things like team logos. It's you have a lot of creative nuances with it, which can be fun, which is why doing sports analysis is fun on the plotting side. So I'm going to show you how to extract team logos and how to plot those essentially for this video. So to give us a little bit of background, I'm going to select a link to one of these teams. So we have the Bills, for example. We want to consider this is the URL. So the base URL is profootballreference.com. And then we have these additional specific links that specify what team you want and the year. So buff for Buffalo and then year for 2024. So this is the summary of the Bills 2024 season. We don't really care so much about that. We care more about this trying to get this logo here, this Bills logo. So if we inspect it, move that out of the way, and then we select our pointer figure, select the image, we see that there's an image with the class team logo and with this source .png. If I copy and paste it in another tab, it loads up the image right here. So this is technically a web address, so we're gonna have to make requests to this PNG image to extract the contents of it. But I'm just showing you that it's there and that you can extract it. So I'm gonna get us back to our code. So what we did last time was we went through how to scrape and then clean out our data frame. And so what I'm going to do is rerun these cells. So that way the kernel knows that this is, well, the kernel saves these variables because these are kind of like a prerequisite to extracting the links. All right. So that should go well for you as well if you followed the second video. Well, I'll do more of the analysis down here. So I'll just say this will be plotting. And then these are some of the libraries I'm going to use. So there's the pillow package, which helps with opening up images from the web. There's matplotlib, which is our plotting package. And there's TQDM, which is the progress bar, which I like to use progress bars to kind of see uh, how far into the process we get. Okay, so a couple things we're going to need to do. So we're going to need to extract. So we need to make a request to the URL. And then within that URL, we want to extract that link, make a request to that extracted link, and then open it into a way that matplotlib can read it. So I'll show an example with the bills. So we're going to need that base URL, which is essentially just profootballreference.com. So we'll just call this base URLs. And then we'll just say the Bills and then their team link. So we'll say Bills URL is equal to df, and then team is the Buffalo Bills. And then we just want the team link. Yeah. So if we look at the Bills URL, and probably because this is still returning a series, aka that zero is still there. So we just do .iloc to get rid of that zero. It returns a string now instead of a series. If we do base URL plus the Bills URL, now we have a full link. If you copy and paste that into a new browsing tab, that website that I showed you earlier will pop up. So we want to make a request. Well, I already have requests up here when I ran that cell, so it's already been imported, so I don't have to re-import it again. So we'll do response equals requests dot get, and then just remember run this in one cell, so that way you're not dealing with rate limiting from Pro Football Reference because Sports Reference limits 20 requests per second, I believe, or I think it's 20 requests per second. Uh, but you can look that up on your own time. We're not going to hit that today as long as you're not rerunning the cell a bunch of times at once. So if we look at the response, 200, which is good. And then we just want to parse it with beautiful soup. Bam. So now we have all that cleaned HTML. And then we want to do soup.find. We want to look for the image tag and then the class, which I forgot what the class was. So let me quickly take a look at it. Team logo. Well, that's pretty intuitive. And then if we do that, all right, perfect. First try. So now it shows us this image tag. If it finds the first image tag, which it's always going to be that logo. And now we only want to get the source, this logo here. So to just extract it, you index it. And now you have this respective link. So we could say logo equals that. And now we need to make a request to this logo. Bam. Should be 200 response. Now we made a request to it. Now we need to properly open it into a way for matplotlib to understand it. That's where the pillow package is going to come into play. So first we're going to do from IO import bytes IO. So we're going to convert the content of that image into bytecode, which is what the image is going to take in, the pillow class. And we're going to do from PIL or pillow. We're going to import image. And then so I'll show bytes IO response dot content. It converts it to bytecode, and then we want to open it. Bam. Now we have the logo properly opened up so that way matplotlib can read it with the bills. Okay. Now we just got to do that for all these 30 teams. Well, I already showed you how to build a function. So we're just essentially just feeding this into a function. So first one is we'll just define it and we'll say, I guess, get image. It's going to require URL, or I guess URL is plural because it's going to return this column here of team links. And then we're going to say for URL and URLs. And before I do that, we want to make a list. So we can do image list because we're going to append each of these opened images to a list. And then we're going to define our base URL in here. So I'll just cut and paste that into here. And then we're going to do, and actually, I want to show you the progress bar too. So from TQ DM import TQDM, or I'll do TQDM URLs, and then we can provide a description. So when we see this progress bar, it'll say extracting URLs, colon, and then our progress. And then we want to say logo, or I guess team URL is equal to the base URL plus URL, which is this down here. And we'll just make a request to it. Then I'll just cut and paste this because we're just going to parse it, parse the HTML. Then we're going to feed it. We're going to find the logo, which will be this down here. So I'll cut and paste this. So now we have the logo URL. So let me just call this URL. So that way it's better name conventioning. So this finds the source for the URL. Now we just got to feed it into this bad boy here. And for cleaning conventions, I'll just make it as a new function so that way you don't see two different responses here. So I'll just say def get a logo, and we'll just say logo URL, and we'll just do response equals requests.get logo URL. And then I'll just keep these libraries up here. And then we're going to open it. Make sure it's indented properly. And we'll say the logo image form is this. And we're just going to return it. So that way we have something to extract. And then we'll just say the logo equals get logo with our logo URL. So now we have this logo extracted from our URL. Oops. Now we want to append that to the image list. And then at the very end, we after this for loop runs, we just want to return that image list. And the last thing I'm going to import is a package called time, because keep in mind we're looping through 30 different links. So we just want to add a sleeping function. So after it's appended, we'll just do time.sleep. And we'll just let that sleep for 5 seconds. Let's do 3. And that's really all to it. Run it so that way it saves that function. Probably should run both, make sure that they're both saved. And then we'll say logos equals to the get image function. And our function or our URLs is going to be the df team link. And then if we run that, there's an error. Logo URL is not defined. Because that should be the parameter that's passed in. Let's just say the URL then. Let's see if that works. There we go. Must be something with my naming convention. Because I thought maybe I misspelled logo URL wrong. That could be why. Logo URL, and then we just feed the logo URL. Keep in mind this is a parameter. It's not a variable name. And we just use that parameter for the requests. All right. So we'll let that run in the background. And after it gets all 32 teams, should be able to start plotting. And in fact, I'll get us started with it. So from matplotlib.pyplot. Oh, I need to import it. And then from matplotlib.offset box import annotation b box and then offset image. These are things that you can use to annotate uh, in matplotlib, like annotate our logos from it. And we'll specify the figure and the axis. This denotes the size of the figure. I usually do 10 by 6. You can make it bigger if you want, but for demonstration purposes, it'll just be that 10 by 6. And what do you know? The logos are done. So in theory, there should be a list of logos. Look at that. So if I do 0, should be the Bills. If we do the last one or -1, the 49ers, 2, the Cardinals, which makes sense because 49ers, Cardinals, yeah. All right, easy enough. Now we gotta plot the dang thing. So, I'm sorry. In order to do like a simple plot in Python, you can do a scatter plot. And what do we want to do a scatter of? So I want to take a look at the relationship between wins and point differential. So we put wins on the x-axis or the independent variable, and then point differential on the y-axis. Oh, I need to make this set equal because it's a parameter. Sweet. So now we take a look at the relationship between The wins, the independent, and then point differential, the dependent variable. Cool. All right. So now we need to get these logos onto here. So how we're going to do this is we're going to have to loop through our list and essentially annotate them onto the plot. So we'll do for logo, and then we want to do wins or win. I mean, let's just do wins and then PD for point differential in. And now this is a new term, zip, which what zip does is it returns a tuple. So if you remember tuples, it's parenthesis, item one, item two, dot, dot, dot. So it's essentially like a list, except it's immutable. And what we want to do is we want to unzip our logos. And keep in mind, this zip will only work if each of these are the same length or same size. And I already noted beforehand, we've gotten 32 logos. And in our data frame, it's the length of 32. So these will be the size 32 as well. So we'll do df wins and then df point differential. If we print, because remember, zip is making this a tuple. So we're essentially unpacking that tuple by assigning these. If we do something like logo, it's going to print out that logo. If we do wins, it'll print out all the wins. And like so. So now we just need to annotate them. To do so, we got to use this annotation bbox and offset image. So we'll do image equals offset image. And let's take a look at what the parameters it takes in. Oops. So it takes things like the array, could specify zoom, all that good stuff. So we're going to specify the logo. Zoom, well, I'll just try 0.1 for now. And what was the last parameter I was thinking of? I think it was resample. So that way the pixels are resampled after we specify the zoom, so that way it doesn't look as blurry. And then we want to annotate it. Equals annotation bbox. I'm going to take in our image. And just to show you, I guess we can use this demo here. So yeah, it takes the image, our XY coordinates. So the XY is going to be wins and point differential. And the last argument, I believe, is frame on, which this one doesn't show. But this one has it. Frame on, so it's defaulted to true, but we don't want that to be true, or else it's going to show like a box on the outside. And then we do dot x, or sorry, x dot, I think it's add, oh, no, it's add artist. Annotation image. We'll do a plt.show. Let's see if this works. And it does. And of course, I can make this a little bigger. Let's just not specify the zoom. Well, that's too big. We'll do 3. Good enough. Now, an issue we're running into here are the colors. So it's not outputting it into RGB, which means we have to fix, I think it was the offset image, because we need to convert it to RGB, or maybe. Mm. All right, so we're going to want to convert it to RGB using beautiful Stack Overflow. So where's the code? Logo equals logo dot convert RGB. There we go. That looks better. Because when we do the annotations, it's taking in the red, green, blue colors. Okay. Now, I believe in the offset image, or was it the annotation B box? We specify the alpha because the only flaw with extracting these images are there's white space in the background. So some images are going to overlap with the others. That's usually why I recommend images from ESPN because those aren't going to have a white background. They're uh, like you can plot them and you can see through the other ones. It's not going to have that white face color in the back. So I'm not going to show you how to eliminate the white pixels because you can do that on this. It just requires going through a NumPy array, and I just feel like that's a little too much for today's lecture. So a workaround would just be specifying the alpha. Oops. And this shouldn't go there, I believe. Yeah. Yeah, specifying the alpha will just make the image just look lighter so that we can see more from the back. Last thing is to get rid of these dots. So after the scatter, we can set the marker and we'll just not set a color. And perfect. If you want to specify it a little darker, you can do 0.5 and that should work. And the last couple of things is just how to annotate the actual X and Y coordinates. So we'll do a plt.x label. We'll call that wins, and then plt.y label. We'll call that point differential. And then we'll do a title. We'll say relationship between wins and point. Just a generic title. So now we have it all annotated here. So you can see lines are towards the top. They have the highest point differential. Chiefs have a lot of wins, but not so much on the point differential side. So yeah, that was essentially all I wanted to show in terms of the plotting. The next one is going to go over a little bit more about the data science side of Python. So modeling libraries like scikit-learn. But today I just wanted to go over how to plot things. So Appreciate the time. If you have any questions, just leave a comment below or just feel free to contact me or the Discord.